Good morning, Morgan, and good morning to any of Morgan's friends that have joined us for this video today. Now, Princess, we've got nearly 4 pages of manual to read, but on the bright side, the next video will be a lot more interesting as we're going to start applying what we're learning today. With that, let's get going.
Python TV58. Python Scopes and Namespaces. Before introducing classes, I first have to tell you something about Python scope rules. Class definitions play some neat tricks with namespaces, and you need to know how scopes and namespaces work to fully understand what's going on. Incidentally, knowledge about this subject is useful for any advanced Python programmer. Let's begin with some definitions. A namespace is a mapping from names to objects. Most namespaces are currently implemented as Python dictionaries, but that's normally not noticeable in any way, except for performance, and it may change in the future. Examples of namespaces are the set of built-in names, containing functions such as abs, and built-in exception names, the global names in a module, and the local names in a function invocation. In a sense, the set of attributes of an object also form a namespace. The important thing to know about namespaces is that there is absolutely no relation between names in different namespaces. For instance, 2 different modules may both define a function maximize without confusion. Users of the modules must prefix it with the module name. By the way,
all right, did you understand that? Because I had a hard time following it. But I guess the namespace, it includes all these methods and go away. All that other stuff when you define the object and all its attributes. And I hope you got more out of that than I did. Let's continue.
By the way, I use the word attribute for any name following a dot. For example, in the expression z.real, real is an attribute of the object z. Strictly speaking, references to names in modules are attribute references. In the expression modName.funcName, modName is a module object and funcName is an attribute of it. In this case, there happens to be a straightforward mapping between the module's attributes and the global names defined in the module. They share the same namespace.
All right. Let's hope that once we start getting into this and start working with this stuff, that this will start to make sense, because even I'm having a hard time following it, but we got to get through this.
Attributes may be read-only or writable. In the latter case, assignment to attributes is possible. Module attributes are writable. You can write modName.the_answer equals 42. Writable attributes may also be deleted with the del statement. For example, del modName.the_answer will remove the attribute the_answer from the object named by modName. Namespaces are created at different moments and have different lifetimes. The namespace containing the built-in names is created when the Python interpreter starts up and is never deleted. The global namespace for a module is created when the module definition is read in. Normally, module namespaces also last until the interpreter quits. The statements executed by the top-level invocation of the interpreter, either read from a script file or interactively, are considered part of a module called __main__, so they have their own global namespace. The built-in names actually also live in a module. This is called built-ins. The local namespace for a function is created when the function is called, and deleted when the function returns or raises an exception that is not handled within the function. Actually, forgetting would be a better way to describe what actually happens. Of course, recursive invocations each have their own local namespace.
Okay, this is actually useful. Okay, it kind of explains what's going on behind the curtain when you're running your in this case what are we using again? Visual Studio. Okay, the interpreter, of course, is the compiler that takes what you've done and put it into machine language. Okay, and the reason why all this stuff is going on in the background and why there's this concept called scope is there's only so much room in the memory inside the CPU. Okay? When the CPU, think of the CPU as a guy sitting at a desk. Okay? And he's only got so much room on his desk. So if he's not using something, he has to put it in the filing cabinet next to him, which is RAM. Okay? And then if he really has to freaking look for stuff, he'll actually have to get up from his desk and go to the library. Okay, that's your hard drive. That's the analogy I use to think of this. Okay, so what they're doing is when they're creating these namespaces, they're making room on that desk. Okay, so the second they don't need it anymore, they take that away and make that space available. But other stuff, the global stuff, they keep on the desk all the time because they know they're going to need it. Okay? So that's what's going on. I hope, of course, they just said that. I'm just saying it a different way. With that, let's keep going.
A scope is a textual region of a Python program where a namespace is directly accessible. Directly accessible here means that an unqualified reference to a name attempts to find the name in the namespace. Although scopes are determined statically, they are used dynamically. At any time during execution, there are...
What the hell does that mean? Determined statically, they're used dynamically. Okay. What the hell does that mean? Statically means that it doesn't move, it's static. And dynamically means it changes. So that, somebody needs to be slapped for writing that. I mean, really, that's confusing.
At any time during execution, there are 3 or 4 nested scopes whose namespaces are directly accessible. The innermost scope, which is searched first, contains the local names. The scopes of any enclosing functions, which are searched starting with the nearest enclosing scope, contains non-local, but also non-global names. The next to last scope contains the current module's global names. The outermost scope, searched last, is the namespace containing built-in names. If a name is declared global, then all references and assignments go directly to the middle scope containing the module's global names. To rebind variables found outside of the innermost scope, the non-local statement can be used. If not declared non-local, those variables are read-only. An attempt to write to such a variable will simply create a new local variable in the innermost scope, leaving the identically named outer variable unchanged. Usually, the local scope references the local names of the, textually, current function. Outside functions, the local scope references the same namespace as the global scope, the module's namespace. Class definitions place yet another namespace in the local scope. It is important to realize that scopes are determined textually. The global scope of a function defined in a module is that module's namespace, no matter from where or by what alias the function is called. On the other hand, the actual search for names is done dynamically. At runtime, however, the language definition is evolving towards static name resolution at compile time, so don't rely on dynamic name resolution. In fact, local variables are already determined statically. A special quirk of Python is that, if no global or non-local statement is in effect, assignments to names always go into the innermost scope. Assignments do not copy data, they just bind names to objects. The same is true for deletions. The statement del x removes the binding of x from the namespace referenced by the local scope. In fact, all operations that introduce new names use the local scope. In particular, import statements and function definitions bind the module or function name in the local scope. The global statement can be used to indicate that particular variables live in the global scope and should be rebound there. The non-local statement indicates that particular variables live in an enclosing scope and should be rebound there. There.
All right. I hope you got something out of that, because that last little bit was just a string of random words stuffed together. The point of writing, the point of speaking is to communicate. And they're just making freaking words up textually. What do you mean textually? What does that mean? Okay, dynamically. Compile time. It's okay. Let's just simplify all this. Like I said, think of this the CPU as a desk, okay? And the computer, it's got everything on the desk and you're working at the desk. And this all has to deal with managing the memory inside the chip and how it reacts with the RAM and the hard drive. That's why they're doing all this, okay? Now, something tells me that you're not going to really understand how this works until you start working with the code. Okay, so what we're going to do is at the appropriate time, we'll go back to this manual and go, oh, that's what they mean. And then I'll spend 30 seconds mocking the author. Okay? All right. With that, yeah, now you know why me and your mommy don't live in the same house anymore. Anyway, love you. See you in the next video.